Hi GeoPrep. Today we'll be talking about proofs with congruent triangles. And with this, today I want you guys to think of yourselves as lawyers, right? We want to prove that we have one triangle congruent to another. And really, we've been given a lot of information previously in order to use our 5 congruence theorems. Remember, those 5 congruence theorems are side, 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 angle, side, AAS, or angle, angle, side, and then angle, side, angle. All of these are congruence theorems that we'll be using. So 4 instead of 5. We'll learn the 5th next week. So right now, we are going to be using a proof. We want to be proving J, or LMJ, congruent to triangle KMJ. I'm going to outline those triangles right now just for us to see those exact triangles that we want to prove. So LMJ and also KMJ. And as you can see, we can probably mark a reflexive segment, that overlapping side that's in both of those triangles. But let's first start with just writing down our givens, like we have, in the past for our regular proofs. So we're going to write down angle JML congruent to angle JMK. And right when I write that down, I'm going to put that in my diagram. So J to M to L is congruent to J to M to K. So those two angles are congruent. The other piece of information we're given is that angle, or MK, is congruent to ML. So I am going to use a green to show you that MK is congruent to ML. So right now we have a side and then we have an angle. What other piece of missing information do we need to put into our proof other than our given information? Remember, our reason for those givens is just given. That reflexive side, though, is JM, right? That is in both of those triangles. So we can say JM is congruent to JM by the reflexive property. Remember in the past when I was like, you guys, you need 3 pieces of evidence in order to prove triangles congruent. Right now we have that. Right now we can prove triangles. We have a side, right? KM or MK and ML. So we have a side. We also have an angle, JMK and JML. So we have an angle. And now we have our third side, which is JM and JM. So really, we have side, angle, side congruence to prove LMJ congruent to triangle KMJ. When you're doing these proofs on the side, I want you guys to highlight, right? We have an angle, we have a side, and then we also have another side. We can use, right? Okay, not exactly in this order, guys, but we can use side and then angle and side to prove triangles congruent. So SAS congruence. Okay, we are going to step it up a gear. So right now it's really just based off our given information that we're able to prove triangles congruent. Now we'll need to form some conclusions based off of our givens. So we'll start with number 2. Number 2, our given information is that UW is congruent to VW. So UW and VW. Put it in my, I put it in there already. We also know that Z is the midpoint of UV. So we really cannot put any other information in this diagram other than Z is the midpoint of UV. We'll make some conclusions, right? What type of conclusion can we make given that Z is the midpoint? Remember that midpoint divides our segment into 2 congruent parts? Okay, I do. So ZU is congruent to VZ. And that is that definition of midpoint, right? If a segment is a midpoint, then it divides, then it divides segment into two congruent parts, right? If midpoint, we were given an endpoint, midpoint, let's form a conclusion. Cool. What else are we missing, right? We have a side, right? We have a side, we have a side. Is there anything maybe that's overlapping between both of these triangles? If we're comparing these two, heck yeah, we have WZ congruent to WZ. By reflexive property. So can we prove that blue triangle congruent to the yellow triangle? Absolutely. And we can do that using side, okay, side, and we have our third side. So using side, side, side congruence, we can prove these triangles congruent. So that will match with our last statement. UZW congruent to triangle VZW. And that's it. Okay. Now let's build on this, right? A new triangle, new pieces of information to be given. Let's take a look at number 3. So based off of our givens, we know R is the midpoint of QS. Okay, cool. We can't put anything in our diagram because we don't know what segments are congruent yet. So all we're going to do is put that in our proof. R is midpoint of QS. Okay. We can also say that angle P is congruent to angle T. We are given that congruence mark, so therefore, I'm going to put that in the diagram, right? Angle P is congruent to angle T. Now, I want to form some kind of conclusion, right? Because right now, we only have an angle to prove TRS congruent to PRQ. So we only have an angle. What type of conclusion can we make if R is the midpoint of QS? R is the midpoint of QS, so it divides that segment into two congruent parts. So QR is congruent to RS. So QR is congruent to RS. Again, just like before, because of that definition of midpoint. So if point is midpoint, or if midpoint, then divides into two congruent segs. Two congruent segments. So now we have a side. Let's take a gander. What other information can we pull from this diagram? Right? Let's see maybe some vertical angles, some reflexive segments. What else can we conclude? Right? I can't see any overlapping segments, right? One triangle is separate from the other. Are there any vertical angles, right? Remember those two straight lines? You know, those angles that are formed by two straight lines that are opposite each other? Let's try these two angles, right? Those are vertical angles. And what's so great about this, too, is I can relabel them. So I'm going to relabel them as 1 and 2. So I don't necessarily have to worry about, you know, using the same language to prove those triangles congruent, right? Trying to match up those corresponding parts. So right now I'm just going to relabel them as 1 and 2. And I need to put that in my diagram. So angle 1 congruent to angle 2. And like I said, you can put it in your diagram and then use it in the proof, but it must be in that diagram. So our reason, vertical angles congruent. Hey, we have our third piece of evidence. So now, can we prove those triangles? Angle, angle, side. Totally. So we have TRS congruent to triangle PRQ by angle, angle, side congruence. So right now, you guys might have mastered, you know, that conclusion based off the midpoint, right? I want you guys to give this one a shot, right? Throw down those givens and see if you can come up with some type of conclusions. In this case, we're not given that it's a midpoint. We're given that we have an altitude. Try to make some kind of conclusions from that. I'm going to start just by writing out that given information and then see if we can form some conclusions. So write out your given information, form a conclusion, and check it back in. go ahead and pause this video. Okay, so you might have had a little couple more steps than I did, but right now I just have my given informations down. I can't make any additional conclusions other than angle 1 is congruent to angle 2. What I can do is think about AC. AC is an altitude. So think about what an altitude does. Right? An altitude divides that opposite side, right, and creates that 90-degree angle. So we can say that ACB and ACD are right angles. And because, I'm so nice, no, because we can also use letters or numbers to describe these angles, I'm going to label them as 3 and 4. So my next step is just going to be that angle 3 and angle 4 are right angles, right? Because we have to go from altitude to right. So if altitude, then form right angles. And then I can go ahead and prove that they're congruent. So angle 3 is congruent to angle 4. And that is right angles are congruent. So right now, what I have is I have an angle, I have another angle, right? I know I have them because of those congruence marks. I need one more piece of evidence to prove triangles congruent. What will that be? Compare BCA to DCA. That third piece is an overlapping segment. So my conclusion is that AC will be congruent to AC by the reflexive property. Now I have my third side. Well, my third piece of evidence, which is a side. Boom, there we go. Comparing this left triangle to this right triangle. I have an angle, I have a side, and I have an angle. Is that side touching both angles? Absolutely. I can form a conclusion that BCA is congruent to triangle DCA. And that is because of angle, side, angle congruence. Okay, this is just the introduction to proofs in triangles. Give the homework a shot. Give those extra practices a shot. Remember, anything that was on that worksheet from yesterday, right? Just recapping our if-then statements is fair game. So any prior knowledge, midpoints, altitudes, medians, make sure you have that down pat. We will be using them to prove triangles congruent now. So incorporating all that together. Homework answers are also posted on Canvas. So make sure, do that worksheet, and then go ahead and on Canvas, check your work. Remember, no use copying, but just check your answers and come in tomorrow with any questions you have. All right, have a good day.